Alright guys, we're going to have a brief lesson on straight line graphs. Alright, it is currently Sunday and it is 6:21 South African time, and what we want to do is to just hit some bases where straight line graphs are concerned. We have already looked at how to look at the form of a straight line graph. If you look at my part 1 of this lesson, that you can actually see that we've looked at that. So grade 9s guys, this is a grade 9 lesson, just for the sake of those who are joining in. This is a grade 9 all the way grade 9 lesson, and we are looking with the grade 9s, we're going to be looking at the straight line graphs specifically. So yeah, yesterday we touched on some other things, so today we are going to look at other things that relate to the straight line graph. Okay, we are going to actually turn our attention now to how do we determine the equation of a straight line graph. All right, yesterday we looked at how to sketch a straight line graph, and today we're going to look at how do we determine the equation of a straight line graph. All right, and in order to assist us with that, let me turn over to a new page so that we can actually maneuver in that direction. So what did I say? Today we are going to look at how to determine the equation of a linear function. So there are questions sometimes that we get asked to actually determine the equation of a straight line graph. So what we need to be able to do is we need to be able to look at a particular set of information, and then from there be able to find the equation, all right, of a particular straight line graph. So we're going to look at that, and we're going to see what kind of scenarios do we have under that heading. Okay, so this is practically part 3 of my linear function series. I've already uploaded onto my YouTube page part 1 of linear functions. Part 2 was uploaded yesterday, so we have that too. Now we can officially look at part 3 of functions as well, and yeah, let's see how that will treat us, and then we will take it from there. Okay, so grade 9s, yeah, this one is for you, but that does not mean that if you are in another grade, a lesson like this you won't benefit from greatly. All right, I'm sorry about the background noise, okay, but it just is part of the surround sound. Okay, determining the equation of a linear function. So let us look at when I say scenario 1, we can look at a kind of situation like this. Okay, if we are given, let's say, the gradient and the y-intercept. Let's say we are given the gradient and the y-intercept. Yesterday we established what the y-intercept is, and yesterday we also established what the gradient is. All right, so gradient is obviously our slope, or in other words, a measure of how steep a function is. Then the y-intercept is simply where the graph cuts the y-axis. So if we are given the gradient and the y-intercept, the question is, how do we determine the equation of a function? So let's say we are told that the gradient is 3, and we are told that this particular line or straight line, it passes through the point 0 and negative 3. Now guys, if you look at the information given here, m is equal to 3 obviously refers to the gradient. If we are told that this line passes through the point 0 and negative 3, what we need to establish is this 0 and negative 3. What is this, guys? What is this? All right, so this is where x is 0 and this is where y is negative 3. We know that when x is 0, we are talking about our y-axis. But the minute y is negative 3, then it means on that y-axis, we are going directly to where our y value is negative 3. So let me repeat this one more time. If they say the line concerned has a gradient of 3, obviously gradient of 3 just means that it has a slope, it's sloping upward, and basically the gradient is 3. But if it says that this line also passes through the point 0 and negative 3, what we need to understand is that this 0 indicates the x value, all right, and then this negative 3 represents the y value. But together, where they meet is on the y-axis at the value of negative 3 on the y-axis. So this would mean that this is actually our what? Our y-intercept. Because remember, our y-intercept, it is where we let x be equal to 0. That is our y-intercept. Now, if we want to determine the equation of a line that has the gradient 3 and passes through the point 0 and negative 3, in other words, it passes through the y-intercept 0 and negative 3, what then would be the equation of that straight line? So what we do is we first write down the general form of the equation of a straight line, which we know is y is equal to mx plus c. Okay, so first and foremost, we write down the standard form of the straight line equation. Then the information that we're given, what are we given? We are given the gradient, which is 3, and the y-intercept, the coordinates of the y-intercept, which are 0 and negative 3. So that means if I come here, the first thing I can now obviously fill in this equation is that m is equal to what? 3. So I can say 3x. All right. Then, do you guys still remember what c represents? My value of c represents the what? The y-intercept. And in this y-intercept, we are saying this is where the graph cuts the y-axis. Now, we are told that the coordinates, guys, these are the coordinates of the y-intercept. Why do we know that these are the coordinates of the y-intercept? It's because at the y-intercept, that's where x is 0, all right? And obviously the output value is negative 3. So therefore we can substitute in the place of c the y value of the what? Of the coordinates of the y-intercept. This would be the value of c directly. Why do we know, guys, that this is the value of c directly? It's because these are the coordinates of the y-intercept. Why do we know it's the coordinates of the y-intercept? It's because when x is 0, our y value represents the what? The y-intercept. So we substitute in the place of c negative 3. Then, obviously, a positive times a negative gives us a what? A negative. So the equation of our straight line is y is equal to 3x minus 3. Done. That is scenario number 1. How to find the equation of a linear function when you are given what? The gradient, which in this case was m is equal to 3, and the y-intercept, which in this case we are given the coordinates of the y-intercept. How were we able to know that these are the coordinates of the y-intercept? Because we know where the y-intercept is. x is 0. And obviously the corresponding y value would represent the c value of our y-intercept, which we can simply then substitute in the place of c, all right, in the standard form equation, the general standard form equation of a straight line function, and then we simply simplify. Positive times a negative is negative, so this is our equation, the equation of the straight line here, where m is equal to 3, the gradient is 3, and it passes through the straight line through the point 0 and negative 3. The equation is y is equal to 3x minus 3. Straightforward, to the point, no hassles. That is scenario 1. When you are given the gradient and the y-intercept, that is how we determine the equation. Now let's take it one step further and go and look at another scenario. Let's say in scenario 2, we are given the y-intercept, all right, and another point, just another random point. Okay, scenario 2 has to do with when we are given the y-intercept and another point. So let's look at an example so that we can see what we mean by this. Let's say we are told that the y-intercept of a particular function is equal to 5. And this line, the straight line function, it passes through the point 1 and 3. So I repeat, we are given that we have the y-intercept and another point, and the question is, how do we determine the equation of a straight line when given the y-intercept and another point? So we were given the y-intercept and another point. How do we determine the equation? So y-intercept in this situation, we are told, is 5. All right, so we are given here the value of the y-intercept. Remember, if we're given the value of the y-intercept, obviously this 5 represents our c value. So our c value is actually equal to 5. And this same straight line, we are told it passes through the point 1 and 3. So what do we do to find the equation of a straight line when we are given the y-intercept, which in this case we are told y-intercept is equal to 5, right? And secondly, this line passes through the point 1 and 3. All right, so what we do is we again start by writing out the equation of the straight line, generally speaking, which is given by y is equal to mx plus c. We'll remember well that m stands for gradient. Our c value is our y-intercept. So it means already, as we can see from the information that we have been given, since we have the y-intercept, since the y-intercept is given to us, we can clearly go, right, and substitute in the place of c. Because remember, what did we say about the y-intercept? The value of the y-intercept is the value of c in the equation of the straight line y is equal to mx plus c. So we can then substitute the y-intercept value, and we can say that the value of c is 5. Where did we get that from? Because we are given the y-intercept. So therefore we can take the 5 and substitute the value of c and say it is 5. All right. What else are we given from the scenario? And we are given another point. All right, another point that lies where the point lies on that particular straight line. So we're given the y-intercept of that straight line, and we are given a point that lies on that straight line, which is 1 and 3. Remember, guys, that 1 and 3 are simply my x and my y coordinate that are points that lie on that line. Okay, so if you have a straight line, for instance, so I'm just giving you an example here. Let's say this is the straight line, and then you have a point that lies on that line, which in this case we are told is 1 and 3. It means that the x value that lies on this line is 1, and then the corresponding y value that basically is an indication of this point is 3. So what do we then do? Okay, so after writing the equation in standard form, and obviously substituting the y-intercept, which is equal to 5, which we know is our c value, all right? And we've done that. Step 1, standard form of the equation. Step 2, substituting the y-intercept. Then step 3, in this situation, we are going to substitute the given point. The given point, which is a point that lies on the line, is 1 and 3. But remember, what does this x stand for? It's just x. What does this 3 stand for? It is just y. What do we need in order to have the full equation of the straight line? We just need the value of m. So in order to get the value of m, this here will be very helpful. We substitute 1 and 3 so that we can find the value of m. So we are going to do that, and you know what? We know that after we are done, we are going to come back to this equation and substitute our value of m. So our form here is nearly complete because we have the value of c, which is the y-intercept. Okay, but what we need is m. In order to get m, we are going to use the point that lies on the line, which is 1 and 3. So let's go and substitute it. This here, this 1 is x, and this 3 is y. So in the place of y, we are going to substitute 3. There it is. Okay, and then m, we don't know yet. In the place of x, we are going to substitute 1. Okay, I repeat. We substitute the point that lies on this particular line, the other point, all right, which is 1 and 3. The x value is 1. So in the place of x, we are going to substitute 1 in brackets. The y value is 3. So in the place of y, we are going to substitute 3. What is the intention? To find the value of m. Then, of course, the rest of the equation has a plus 5. Now let us solve for m. Step number 4. Let's go ahead and solve for m. So 3 is equal to what's m times 1? It's m plus 5. Now we take the 5, we transpose it, it becomes 3 minus 5. We isolate the m. Now we can find what the value of m is. What is 3 minus 5? It is negative 2. Therefore, the value of m is negative 2. So now we can conclude. Remember, this equation was waiting patiently. Waiting. Oh my God. Waiting so ever patiently. This equation. Waiting for us to find m. Our lifesaver here was the point 1 and 3. It saved the day. It helped actually replace the y value here being 3, and then it helped replace the x value being 1, so that we can then be in the position of solving for m, the unknown, all right, and then getting what the value of m is, which is negative 2. Now that we have the value of m, we can now conclude about the equation of the straight line. Y is equal to, our m value, guys, is what? Negative 2. Followed by what? Followed by x. Followed by what? Plus 5. So this is the equation of the straight line. Okay. Really, really straightforward. Okay. Scenario number 2, when we are given the y-intercept of the particular function, the straight line function, and another point that lies on the line. This is how we would go about finding the equation of the straight line. All we simply do is we take the y-intercept, the value of c. We know that c corresponds with the y-intercept. We substitute it into the standard form of the equation of the straight line. C, in the place of c, we write 5. Then we are missing m. We take the other point, we substitute it into the respective 1 is x, 3 is y. So in the place of y, we have 3. In the place of x, we have 1. Then we solve the equation. Okay. 3 is equal to m times 1 is m plus 5. We transpose the 5 to the left-hand side. 3 minus 5 on the left-hand side. 3 minus 5 is negative 2. Now, therefore, the value of m is equal to negative 2. And then we can conclude about the equation. Remember, we are waiting for m. We now found it. We substitute it. We get the equation y is equal to negative 2x plus 5. Okay, so that is how we would deal with scenario number 2. When we are given the y-intercept and another point that lies on the line, that is how we would go about finding the equation of the straight line. All right. Okay, moving on. Scenario number 3. Grade 9 Lwami, grade 9 Lwami. Okay, I'll be hosting the grade 12s later on this evening actually. Okay, let's say grade 12s at 9 p.m. I'll have a session with you guys, 9 p.m. All right, I'm just trying to get my grade 9s in the mix here. So the first number on the coordinate is always x, and the second is always y. Yes, Mini, yes. This here is the x value, very true. In our points, the coordinates, the first point on our coordinates is x, the second point on our coordinates is y. Primrose, I'll have a session with grade 11s at 8. Let's say 7:30 or 8, okay? Because I will end this session, let's say 8 actually. Let's not say 7:30. So at 8. And is there something in particular you would like to be done in that session, given what you guys are doing, having opened the term as grade 11s? You can tell me, Primrose, what would you like done? Okay. All right, so y is equal to mx plus c, y is equal to mx plus 5. I hope we understood scenario number 2. When we are given the y-intercept in another point that lies on the line, that's how we go about finding the equation. So let's look at another scenario. Scenario number 3. What about when we are given the gradient Okay, let's say we are given the gradient and a point. Okay, very different from this one. This one was very specific. All right, given a gradient and the y-intercept, very straightforward. Okay, because if we're given the y-intercept, we know that's the value of c. Okay, and if we're given the y-intercept, we know that's the value of c, right? And remember, I explained this, that this point 0 and negative 3 is a representation of the coordinates of the y-intercept. Why? Because whenever x is made to be 0, the y value would represent our c value, which is the y-intercept. So we can substitute c is equal to negative 3 here, because it is exactly our y value that we substitute in the place of c whenever we have a point that is x is 0, whenever x is 0, we are dealing with the y-intercept, guys. So that coordinate means it's the point that represents the y-intercept. Very much straightforward. So in this situation, it was very straightforward. We just substitute the gradient in place of m, we substitute the y-intercept in the place of c, and then we just sort out the sign, positive times the negative, voila, no problem. Scenario 1 was straightforward. Scenario 2, we have the y-intercept and another point that lies on the line. If you are given the actual value of the y-intercept, that is the c value, so we first substitute that, then we use the other point to find the value or solve for the value of what? Of m. Okay, and we did the substitution here, substituting the point where x is 1, y is 3, and then the substitution was pretty nice. We solved for m, we substituted the m value back into the equation. That is the equation of the straight line, y is equal to negative 2x plus 5. Now we are going to look at scenario 3. When we are given, what about when we are given the gradient and a point? So let's look at this. Let's say, for example, we are told that the gradient of a particular point is negative 5 and it passes through the point. Now let's check the point. The point that it passes through is 4 and 1. So I repeat, we are given a particular scenario where we are given the gradient and a point. If we are given the gradient and a particular point that the line passes through, all right, let's say the gradient is negative 5, and then we are told specifically that it passes through the point 4 and 1, this particular straight line. And the question is, find the equation. Because here, guys, all we are doing is finding the equation of a straight line, of the linear function. How then will we find the equation of this line? Okay, so we are told the gradient is negative 5 and this particular line passes through the point 4 and 1. Okay, now we are going to do what we've been doing even in other scenarios, and it seems like our first safe option is to write down first the equation of the straight line, y is equal to mx plus c, the way we know it ought to appear in standard form. Y is equal to mx plus c. What does m stand for? Gradient. What does c stand for? Y-intercept. Okay, yeah, yes guys, every single time I have another point, it just means that particular line, whether it's a positive straight line or a negative straight line, if I talk about passes through a point, it means that there's a point that lies on that particular line. And in this situation, the gradient is negative 5, so we're expecting a decreasing straight line, of course, and the point that it passes through, this line, is 4 and 1. So it just passes through the point. Okay, yeah. So here we are talking about a line passing through a point. In each and every situation that I've been doing, scenario 1, okay, we are given the gradient. Scenario 1, given the gradient and the y-intercept. In other words, a straight line that has a gradient of 3 and passes through the point 0 and negative 3. And we established what this point actually is, that it's more than just a point, but it is actually the point which we refer to as the y-intercept. Scenario 2, we are given the y-intercept and another point that lies on this particular line that we're trying to find. So here in this case, we are given the y-intercept, which is the actual value of the y-intercept, all right, which we know is c, okay, and then it passes through the point 1 and 3. So once again, a line that passes through a point 1 and 3. We dealt with that scenario. Now we are in scenario number 3. We are given what? The gradient, and this particular line passes through the point 4 and 1. Now we need to find the equation of the linear function. So what I said now is that we always start there and we say, okay, what is the general standard form of a linear equation? Y is equal to mx plus c. I just want to stop here and say, sometimes in other textbooks, you'll find that this M and this C are replaced by other letters. Maybe there will be an A here and a Q there. Guys, doesn't matter what letters they are. All we need to understand is that the coefficient of X stands for the gradient, and then whatever the constant value is, whether it's you write a Q letter or a K letter or a T letter, whatever letter it is, this stands for the y-intercept. So from the information that we've been given, we've been told that M is equal to -5, and this particular line passes through this point. So immediately from the information I've been given, what can I then say? I can say y is equal to, in the place of M, I can write -5x. And then I can write my plus C, all right? And this here means that I have M. I'm just missing the value of C. And unfortunately, from the information that I've been given, I do not have the value of C explicitly given to me. Or in other words, it is not just there for me to take and write in. I have to find the value of C. How? I'm going to find the value of C by substituting the point 4 and 1, which is a point that lies on the line. I can always substitute the point that lies on this particular line to find an unknown variable like C, which I want to find. So let's go and find the value of C by substituting the point. Let's rewrite that equation. It's -5x plus C. Passing through the point who? 4 and 1. Who is 4? It is my x coordinate. Who is 1? It is my y coordinate. The point that lies on this line. So let's go ahead and substitute. Let's substitute 4 and 1 into the equation. Why are we doing that? To find C. Why are we doing that? To find the value of C. So let's go. Who belongs to y? It is 1. 1 is equal to, in the place of y, I write 1. Equal to what? -5. In the place of x, who am I substituting? 4 plus who? Plus C. Okay, I hope you are with me, grade 9. It's very important, this thing. Then I multiply to find C, and then I transpose, I solve for the unknown C. Solving for an unknown should not be a pain, because as a grade 9 learner, I am so well versed in solving equations, because in term 2, this was my daily bread and butter. So -5 times 4, that is -20. We have 1 on the left hand side, plus who? Plus C. We transpose the -20 to the 1. It joins 1. It becomes +20. We isolate C. Now I know most of you are used to be the unknown being on the left hand side. It doesn't matter where the unknown is, guys, as long as it is isolated and it is positive. So what's 20 plus 1? It is 21. So what is the value of C? The value of C is 21. Therefore, we say C is equal to 21. Who was waiting for C? It was the equation. It was waiting for C. Who was waiting for the C value? It was the equation. It was waiting for C. So can we now fill in the value of C? Yes, indeed we can. The equation of the straight line is y is equal to -5x plus who? Plus, the C is positive as well, so it's plus 21. There's the equation. Pretty straightforward scenario if you ask me. All right. When we are given the gradient and the what? Another point. This is how we find the equation of the straight line, very simply and straightforward. So step 1, what did we do? We wrote the equation in standard form. Step number 2, we substituted m is equal to -5 in its place. Step number 3, we used the point 4 and 1. Step number 3, we used the point 4 and 1, which lies on the line, to find who? To find C. So we did that. We know 4 represents x, so 4 goes in the place of x in brackets. Y is represented by 1, so in the place of y we substitute 1. Then we solve for who? For c. So we did that here. Negative 5 times 4 is negative 20. That's 1 on the other side. We took negative 20 over, it becomes positive 20. We add, we get 21. The value of c is 21. The equation of the straight line is y is equal to negative 5x plus 21. Okay, beautiful scenario. Scenario number 3. All right. I hope you guys loved and enjoyed scenario number 3. Okay. So I'm going to do one last scenario. Scenario 4. Are you ready for scenario 4? Scenario number 4 has to do with when I am given 2 points that lie on the line. You are given what? 2 points that do what? That lie on the line. The question is, what do I do to find the equation of a straight line if I'm given 2 points that lie on the line? Given what? 2 what? Points that what? Lie on the line. Lie on the line. Scenario 4. So let's look at an example so that we can more fully appreciate this scenario. 2 points, negative 1 and 2, and 3 and 4 lie on the line. Find the equation of line. Find the equation of the line. How do we find the equation of the line if we are given 2 respective points that lie on the line? Sometimes they don't even give it to you in words, but they will give you the actual straight line. You'll have a straight line, maybe something like this. You know what I mean? Then what will happen is they will literally be like writing here negative 1 and 2. That will be that point there. And then here they'll write 3 and 4. They give this to you in the test, right? They give you the straight line. It's drawn like that. And then all you see is those 2 points, negative 1 and 2, okay? And then you have 3 and 4. And then they just say, find the equation. All right, so this is a graphical representation of the very same question. Okay. Oh, look at Lesego, look at Lesego. Lesego is like ahead of the game. Yes. You are absolutely stunner, 100% correct. Okay, but before we even do that, Lesego, all right, what's important here is to note that we know that as we begin this question, we are beginning with the mindset that we want the equation y is equal to mx plus c. At the end of the day, we need to find the value of m, we need to get the value of c, so that at the end of the day, we have an equation that has both of these components, m, the gradient, c, the y-intercept. So you are definitely 100% correct when you are saying, are we going to do the y2 minus y1 divided by x2 minus x1 to find m? And I say to you, yes. So thank you so much for actually saying that. You are 100% correct. Lesego. Go, Lesego. All right. So yes, indeed. All right. So we are going to say to ourselves, well, seeing as though we have 2 points, can we find the value of m? All right. And step number 1 is yes, we can. All right. Because if you remember from what we did in the previous live session that we held, we did say that if the gradient of a particular equation is not given to us, if ever we do have the 2 points 2 points, any 2 points that lie on the actual line. If there are any 2 points that lie on that actual line, then we can go ahead and actually use what, guys? We can use the formula. Which formula? This one. Okay? The formula to find gradient between 2 points is the formula that says y2 minus y1, which is, in other words, it's the change of y over x2 minus x1, which is the change of x. And yesterday we did emphasize that whenever we use this formula, guys, it's so important that our y2, if it's first, then we need to make sure at the bottom x2 is also first. Our 2's need to start together, our 1's need to end together. If we start with y1 and say y1 minus y2, then we need to start here with x1 minus x2, so that at the end of the day, our gradient does not lose its significance. All right? So thank you, Lesego. You're 100% correct. So our points are what? -1 and 2. The other point is 3 and 4. You then must go ahead and decide, my dear beloved friends, if this is your first point, then it means you are going to say this is x1 and this is y1, because it is your first point. If then you say this is your second point, then it means this is going to be x2 and this is going to be y2. You see, my friends? So easy, no? Easy like a peasy, like a cheesy. Like a mizzy, like a dizzy, like an easy. So easy like a mizzy, like a dizzy, like a cheesy. Like a cheesy, like a dizzy, like a easy. Alright? Now, all we do, we substitute. Y2, Y1, X2, X1. Negative times a negative is positive. Very important, this part, guys. 4 minus 1, very straightforward. You see that? Hey, what error is this? Y2 minus Y1. Error. 4 minus 2. My bad. Y2, 4 minus Y1, 2. Okay, now guys, this error that I've just made here is a very common one, where you have labeled, you've clearly labeled your intercepts. All right, yes, Sparkle, I'm calculating the gradient. You've clearly labeled your intercepts, I mean your x and your y coordinates, but then what you do is you write the wrong number where you ought not to. So y2 is 4, y1 is 2. The negative sign is already there in the formula, so you must make sure it's there. At the bottom, x2 is 3. The minus sign already in the formula. X1 is also -1, so you must make sure you put it in brackets. Please, please, please. So that the negative times the negative, you know, is what? It's positive. What's 4 minus 2? This is rubbish. 4 minus 2 is 2. Okay, 3 minus minus 1, that is 3 plus 1, which I know is 4. So we have 2 over 4. What's 2 over 4? We simplify it, guys, because it's very important that we simplify it. So that means our gradient for this particular equation is half. So that means I'm going to have a gradient that I can fill in there in that spot of M. Okay? So that I'm one step closer to getting to my destination answer, which is very close. Now all I need is what? Is C. So I go there, I write y is equal to half what? Half what? Half x plus who? Plus C. right? Some people would write this equation as y is equal to x over 2 plus c. Guys, both ways of writing this are 100% correct. Please note that this x is not in the denominator. It is not in the denominator, but it's an x that's in the numerator. But when you write it down, if you want, you can write it as half. And please write the x in line with the divide sign, so that it is clear that this x is not an x that's in the denominator, but it's an x, yes, that's written midway, but it is actually an x that is supposed to be in the numerator. So you can write y is equal to half x plus c, that's acceptable, or you can write it as y is equal to x over 2 plus c. I hope it makes sense, guys. Either way is acceptable. You can write it this way or that way, but let's never think that this x is an x that's in the denominator. It's not. It is not, guys. It's absolutely unacceptable to write this x as if it's in the denominator. It's not in the denominator. It's an x that's actually in the numerator. Okay, so this is more acceptable than actually writing that x in the denominator. It's x in the numerator. Okay, so you would be right in writing it this way or that way. It doesn't really matter. Then let's go. What I love about this way is that you can clearly see that, okay, the coefficient of x is half. All right, yeah, the gradient is half. Then all we do is we substitute what? You can choose, guys. You can choose to substitute 0.1, or you can choose to substitute 0.2. It's up to you. But me, I'm just going to go ahead and substitute 0.1. But guys, you are free to choose any. I'll show you that the answer will be the same. I'll substitute this one first and then show you substituting the other one, how the answer will stay the same. So if we substitute, that means this is my x, this is my y. So in the place of y, I write 2. In the place of x, I'm going to write -1. Okay, then we have 2 is equal to -half plus c, because remember, half times -1 is -half. We transpose the half. 2 plus 1 over 2 is equal to c. Then you can add this, right? You can take your calculator and add it quickly if you want, but we know that the addition of fractions for this will give us a 5 over 2. So c is equal to 5 over 2. Therefore, we can say y is equal to half x plus 5 over 2. Gefällt. Done. All right, there's the equation. All right, so with this scenario, you first use your points to calculate the gradient. Once you have found the gradient, you go and substitute the gradient in the place of m. There it is. In the place of m, you then substitute the gradient. Very important, because m is the gradient. Now you can write y is equal to half x plus c. Who's missing? C. In order to find c, you can take any of these 2 points, substitute it into the equation. That will help you find the value of who? Of c. Hey, then after finding c, you then go back here and you substitute the value of c into the equation. So now you have the equation of the straight line. Y is equal to half x plus 5 over 2. Okay, not too bad. Okay, not too shabby at all. All right, 4 great scenarios, guys. How do we find the equation of a straight line? These 4 scenarios, guys, are a solid foundation for any learner in grade 9 who's saying that, you know what, sir, I want to make sure that with the graphs, I know how to sketch the graph. I need to make sure I know how to find the equation of a straight line. These guys are the keys to ensuring that we are able to do all of those things. All right. Okay. So that basically brings me to the beautiful end of my lesson with y'all today. I think I'm going to leave you guys with some game challenge questions. All right. Okay. I'll leave you with some game challenge questions. I think it would not be fair if I didn't. Then what I will do is, I know I haven't been doing that for the previous live lessons, but let me just do that now. Part 1, part 2, part 3. I think yeah, let's leave some game challenge questions, a sizable number. All right, so the first one, following up on, write each of the following equations in standard form, and then determine M and C. Okay, so this would be in line with what we have done so far, all right, since even part 1. All right, and guys, remember that all these other parts of the straight line graphs are found in my the YouTube link. You can find it in my bio. The videos of the previous live lessons for this particular section of work is found there, so you can always check that one out. So you can, yeah, let's answer these ones well. Okay. Right, so that's the first 3, writing each of the following equations standard form and then determining M and C. So that's 1. Let's look at 2. Determine the gradient. So these questions just want the gradient between the 2 points. So let's write A 12 and 5, B 15 and 2, okay, and then lastly 3, which is in conjunction with what we did today. Actually not yet. Sketch the following graphs. Sketch the following. Let's sketch the following. Y is equal to 3x B. Now you will know the method to be used according to what I'm writing down. Okay, you will know exactly which method to use because I explained quite a few things yesterday. All right, actually let's be specific here. Okay, so let's do that. Here we can use the dual intercept method. So let me just be specific here so that I can facilitate understanding for some people. For x plus 2y is equal to 8. So okay, this is sketching number 3, and then 4. So guys, I'm gonna actually not be live for a few days so that I can give you enough time to actually cover these aspects of the grade 9 linear functions, and then we'll do the corrections the next time we have a live session. Hello, Miss Green. So we'll do the corrections the next time, and then 4 will be in conjunction with what we did today, which is determining the equation. All right, so let's determine the equation. All right, so that will be covering all game challenges with regards to what we've done so far in straight line functions. Determine the equations of the linear function. Okay, and these are the various conditions. So the first one will be where the gradient is 2 and the y-intercept. Thank you, Eunice. Thank you, guys. Thank you for the support. Really appreciate that. That's nice. So the gradient, where the gradient is 2 and the y-intercept. Please don't mind my writing, guys. I do believe that in my past life I was supposed to have been a doctor, but yeah, it just didn't fly. That's why the writing is not really flying so well. Gradient is 2 and the y-intercept is -4. Okay, B. Gradient is -1. Okay, and the line passes through the point 0 and 2. Okay, then C. Thank you, Eunice. My goodness, Eunice is like pumping it up with the gifts. Thank you. Appreciate the roses. Really appreciate. Thank you so much. The gradient is 3 and passes through the point 1 and 6. Okay, then D. Gradient is -½ and passes through the point -4 and 2, and then E. -2 and 2, 6 and -1. I want the equation then. Then lastly, the y-intercept is equal to -1 and okay, so that's it, guys. I think that's a meaty meal. All right, and I hope you guys will enjoy that. So let's get this done. I think I'll give you guys sufficient time, not now obviously, but like, I mean, it would be cool if you are able to, when I end the live, if you are able to immediately after the live actually go ahead and do these, so that you can see like how much you comprehended from what we've just covered. Then that would be great. Thank you, Eunice. Because that way you are able to like hammer in. So you don't necessarily have to go and start with number 1. If the burning issue after having taught you is this, because remember I just taught you guys how to answer questions based on number 4. So if you guys can go ahead and do this immediately. You cannot see the last question. Sorry. So the last question is when the y-intercept is equal to -1 and passes through -2 and 3. Okay, sorry. Like I said, guys, I believe in my past life, maybe I was supposed to have been a doctor. I just, decided to teach and assist others to become that. But like, yeah, y-intercept is equal to -1 and passes through -2 and 3. So this last segment, this one, will correlate exactly with what I've just taught you guys, how to determine the equation of the linear function. I've just taught you various scenarios that we can experience or expect, whereby we are required to find the equation of the straight line. So please, guys, go ahead and do this. All right, so number 4, A to F, obviously will be most burning because it's immediate. It's like hot off the press. Guys, you know, most the best time to eat baked bread is immediately after it's just come out of the oven, right? Because it's hot and warm and good and wholesome, and you can actually experience the goodness of that particular baked, thingamabob. So you need to also, if I've just taught you and you felt like, yo, this was good and I think I've got it, I'm telling you guys, don't believe what your mind says. Your mind will tell you, no, you've got it. No, you haven't got it. I've got it. I'm the one who knows it. I taught you, so I know it. But if you want to know it as well as I do, then go ahead and do it immediately and check yourself out and see. All right. Then when I do the game challenge questions and do the corrections next time, then you'll be able to say, that was easy, I got that down. Please also don't feel like you have to wait until the next game and the next session to actually send me your work. Guys, do use the inbox message. That's the best thing to use the DMing for. You can actually take pictures and send me your work so I can see what you did, and trust me, I'll check it out. I'll give you feedback. I'll let you know if you are in the right direction or not. All right, so if you have any questions, you can ask in the comment section. And those who are obviously in my who are privileged to actually have one-on-one contact with me via WhatsApp, you guys can actually send me your work immediately after you are done, so I can check it out and give you feedback as soon as hot off the press. And remember the other questions that are here. All right, write each of the following equations standard form, then determine M and C. This was part of part 1 of the work that I covered with you, so that's already work uploaded on my YouTube channel. Determine the gradient between points. We did that yesterday, so that's in part 2. That's also uploaded in the YouTube channel. And then this as well, sketching the following. How to sketch a function. I'm going to leave this open. I've told you directly what you need to do here using the table method. Here I've told you using the dual intercept method, but here I'm expecting you to know exactly what method you ought to use as I explained yesterday. And then of course this is with regards to what we did today. Guys, there's more coming up on straight lines. I am definitely going to be taking you through the last bit of what straight line functions have to offer. I want those who may probably be doing geometry already in their respective schools in grade 9. Yeah, I've already uploaded videos on geometry. Like there's a series that I started like during the holidays. So you guys are more than free and welcome to actually check that out on my YouTube channel as well. There's like, I think 5-part videos that I've already uploaded there. We've done straight line angles, like angles that lie on a straight line, complementary angles, supplementary angles. We've done parallel lines, angles between parallel lines, using the correct reasoning as well, because that's important as well. So I've actually gone through like how to utilize the right reasoning, because it's very important to use the right reasoning in geometry. Okay, so check that out as well. And yeah, okay guys, that's it. Thank you so much. I hope you guys enjoyed the session as much as I did. I know there was not a lot of commentary in the comment section, but I'm hoping you guys were listening quite well and that it was a fruitful one. So my grade 12s, I'm going to see you guys at 9 o'clock. Grade 12s at 9 o'clock, grade 12s at 9 o'clock. I'll be seeing you at 9 o'clock. I'll have a session with the grade 12s at 9 o'clock. Then at 8, I'm going to have a session with the grade 11s. So I'll be back here again at 8 o'clock. Now I need to love and leave you. Thank you so much. Much love to all of you. And thank you so much, Mrs. Him. Thank you so much for the GG. So once again, I just said yesterday to Mrs. Him and to those that were here in the platform yesterday that the GG means genius, you know, the God-fearing geniuses. That's the kind of people I have on my, you know, Maths as a Game platform. Those who are maths gamers are like just GGs. GG stands for genius, and those are the kind of people that get high top Shaila marks. So yeah, I hope this also helps facilitate you guys being able to have a solid grounding understanding of the maths as you enter into the term that you are currently in. It's week 2, guys. Everything of the best with this week, you know. Please make sure that you do your homework when it's given to you by your maths teachers. Maths is a subject that you have to constantly be doing. If you want to get good at it, if you want to get high marks, if you want to like kill it, if you want to destroy the maths and just do amazing stuff, then you need to make sure that you are doing the best that you can do by making sure that you are practicing. And yeah, thank you so much again, and have a good one. It was really good. I'm going to see, like I said, grade 11s I'll be seeing you at 8, grade 12s I'll be seeing you guys at 9 p.m. today. Thank you. Cheers. Bye.